Have you ever wondered what would happen if you woke up tomorrow and suddenly felt twice as heavy? What if gravity, the invisible force that keeps us grounded, suddenly became twice as strong? This isn't just a thought experiment. It's a fascinating journey into physics that reveals just how perfectly balanced our planet really is. Today, we're diving deep into a scenario that would fundamentally transform life as we know it. What if Earth's gravity suddenly doubled from 9.8 meters per second squared to 19.6 meters per second squared? The consequences would be immediate, dramatic, and far-reaching. Imagine waking up tomorrow morning and trying to get out of bed, only to find that your body feels impossibly heavy. Your legs buckle under the weight, your arms feel like lead, and even lifting your head becomes a monumental effort. This is where our journey begins, in a world where the fundamental force that governs all motion has suddenly become twice as powerful. Understanding gravity's role. Before we dive into the chaos of doubled gravity, let's understand what we're dealing with. Gravity isn't just the force that makes things fall, it's the architect of our entire existence. Every step you take, every breath you draw, every beat of your heart has been shaped by Earth's current gravitational pull over millions of years of evolution. At 1 g, Earth's gravity is already incredibly powerful. It's what keeps our atmosphere from floating away into space, what maintains the perfect pressure for liquid water to exist, and what has guided the evolution of every living creature on our planet. Consider this. A hummingbird's wings beat up to 80 times per second, perfectly calibrated for Earth's current gravity. A giraffe's heart pumps blood with just enough pressure to reach its brain against our planet's gravitational pull. But what happens when we suddenly crank that dial up to 2 g? Let's find out. The immediate physical impact on humans. The moment gravity doubles, every human on Earth would experience an immediate and shocking transformation. You would instantly weigh twice as much as you do right now. If you normally weigh 150 pounds, you'd suddenly feel like you weigh 300 pounds. But here's the crucial point. Your muscles, bones, and cardiovascular system would still be designed for the original weight. Standing up would become a monumental challenge. Your leg muscles, which have been perfectly calibrated to lift your body weight against 1 g, would now struggle under this doubled load. Walking would feel like you're constantly carrying another person on your back. Simple tasks like climbing stairs would become exhausting ordeals that leave you breathless and shaking. Your cardiovascular system would face immediate and severe stress. Your heart, which has been perfectly calibrated to pump blood against Earth's current gravity, would now struggle to circulate blood throughout your body. Blood would have a much harder time flowing upward from your heart to your brain, potentially causing dizziness, fainting, or worse. Imagine trying to stand up quickly, something we do without thinking hundreds of times a day. In a doubled gravity environment, this simple action could cause you to black out as your heart struggles to pump blood against the increased gravitational force. Your blood would literally be twice as heavy, making circulation a massive challenge. Your spine would compress under the increased weight. The vertebrae that protect your spinal cord would experience double the pressure, potentially leading to immediate back problems and long-term skeletal issues. Even your internal organs would feel the strain, as they'd effectively double in weight while your body structure remains the same. Breathing would become laborious. Your diaphragm would have to work against doubled gravitational resistance. Each breath would require more effort, and many people would experience symptoms similar to being at high altitude, but for entirely different reasons. The atmospheric catastrophe. While humans struggle with their new weight, Earth's atmosphere would undergo a dramatic transformation. With doubled gravity, the atmosphere would compress significantly, fundamentally altering the air we breathe and the weather patterns we know. The air pressure at sea level would increase dramatically, creating conditions similar to being deep underwater. This atmospheric compression would have several immediate effects. First, the air would become significantly denser, making it harder to breathe. Your lungs, designed to work with current atmospheric pressure, would struggle to expand and contract efficiently. The increased density would mean that each breath contains more oxygen molecules, but paradoxically, it would be harder to extract that oxygen due to the physical effort required to expand your lungs against the increased pressure. Many people would experience symptoms similar to altitude sickness, but in reverse. The weather patterns we know would be completely disrupted. Storms would become more intense and violent due to the increased atmospheric pressure and density. Rain would fall harder and faster, as water droplets would accelerate toward the ground at twice the normal rate. Hurricanes and tornadoes would become exponentially more dangerous, with the increased atmospheric density allowing these storms to carry more energy and cause more destruction. Even the sound of wind would change. Sound travels differently through denser air, so the auditory landscape of our world would be altered. The whistle of wind through trees, the sound of rain on rooftops, even human voices would sound different in this new atmospheric environment. Impact on wildlife and ecosystems. The natural world would face an immediate crisis of unprecedented proportions. Every species on Earth has evolved over millions of years to function perfectly in our current gravitational environment. Doubling that force would create an ecological catastrophe that would reshape the entire web of life. Birds would find flight extremely difficult or impossible. Their wings, perfectly designed for generating lift in 1G, would be insufficient for 2G conditions. Many bird species would become effectively grounded overnight. Migratory birds would be unable to complete their journeys, disrupting global migration patterns that have existed for millions of years. Large mammals would be particularly vulnerable. Elephants, giraffes, and other massive animals would struggle to support their own weight. Their legs and skeletal systems, already at the limits of what's possible in 1G, would likely fail under doubled gravity. An elephant's legs, which can currently support up to 6 tons, would suddenly need to support 12 tons with the same bone and muscle structure. Even smaller animals would face significant challenges. Insects, which rely on precise flight mechanics, would find their aerial capabilities completely disrupted. Bees, crucial for pollination and food production, might be unable to fly efficiently. This would threaten not just bee colonies, but the entire agricultural system that depends on insect pollination. Trees and plants would face their own unique struggles. Tall trees would have difficulty pumping water and nutrients from their roots to their leaves against the increased gravitational pull. Many trees would likely topple under their own increased weight, fundamentally altering forest ecosystems. Aquatic animals would fare better, as water provides buoyancy that counteracts gravity. However, even they would feel the effects of increased pressure. Marine mammals that surface to breathe would find it more difficult to break through the water's surface against the increased gravitational pull. Geological and structural consequences. Human-made structures would face immediate stress as they suddenly experience double the gravitational load they were designed to handle. Skyscrapers would be particularly vulnerable. Their foundations and support systems would face unprecedented stress. Some buildings might collapse immediately, while others would develop dangerous structural weaknesses. The entire field of engineering would need to be reconsidered. Load-bearing calculations, foundation designs, and structural materials would all need to be completely reassessed. Bridges would suddenly face double the stress on their support structures. Ancient structures and historical buildings would be at particular risk, as many were constructed with smaller safety margins than modern construction. On a geological scale, the Earth itself would begin to respond to the increased gravitational force. The planet would compress slightly under its own increased weight, potentially triggering earthquakes and volcanic activity. Mountain ranges might become less stable, and landslides would become more common and destructive. Technology and transportation crisis. Our technological infrastructure would face immediate and severe challenges. The aviation industry would be completely grounded overnight. Aircraft wings and engines are precisely designed for current atmospheric conditions and gravitational forces. Commercial aviation would cease to exist until entirely new aircraft could be designed and built. Satellites orbiting Earth would be pulled into lower orbits by the increased gravitational force. Many satellites would begin to decay rapidly, eventually crashing back to Earth. Our GPS systems would become increasingly unreliable as satellite orbits decay. Communication networks and weather monitoring systems would be severely disrupted. Even ground-based technology would struggle. Vehicles would need more powerful engines to move the same distances, experiencing reduced performance and dramatically increased fuel consumption. Construction equipment would find their rated capacities effectively halved, making infrastructure repair much more difficult. Long-term adaptation and evolution. If this doubled gravity scenario persisted, life on Earth would need to adapt or perish. Human beings would likely undergo significant physiological changes over just a few generations. We might develop stronger bones, more powerful muscles, and more robust cardiovascular systems. However, this adaptation would come at significant costs. Human height would likely decrease substantially, as taller individuals would face greater disadvantages. Our body proportions might change dramatically, with shorter limbs and more compact torsos becoming advantageous. The evolutionary pressure would be swift and merciless. Species that couldn't adapt quickly would face extinction, while those with advantageous traits would proliferate rapidly. Agriculture would need to be completely reimagined, with crops developed that can grow in high-gravity conditions. Scientific innovation and silver linings. Interestingly, doubled gravity might accelerate certain scientific advances. The extreme challenges would drive unprecedented innovation in materials science, medicine, and engineering. We might develop new materials that are stronger and lighter than anything currently available. The medical field would rapidly advance treatments for cardiovascular stress and bone density issues. New technologies for supporting human health under extreme conditions would emerge, potentially including advanced exoskeletons or assistive devices. Transportation technology would need to advance rapidly. We might develop new forms of propulsion and vehicle design that are more efficient under increased gravitational stress. These advances could revolutionize transportation systems. Psychological and environmental changes. The psychological impact would be profound. Humans would need to adapt mentally and socially to a world where basic activities become challenging. Many jobs would become impossible, and social structures would need to change dramatically. The environmental impacts would extend far beyond atmospheric compression. Ocean currents would be affected, potentially leading to dramatic changes in global climate patterns. The water cycle would be fundamentally altered, and sea levels might change as the increased gravitational force affects the Earth's shape. Conclusion. The scenario of doubled gravity reveals just how perfectly balanced our world really is. Every aspect of life on Earth has been shaped by the precise gravitational force we experience today. While the immediate consequences would be catastrophic, it also highlights the incredible adaptability of life. This thought experiment reminds us that we live on a planet with conditions precisely calibrated for life as we know it. The next time you take a step or simply stand up, remember that you're experiencing one of the universe's most fundamental forces, a force that has shaped everything you see and everything you are. What do you think? Could humanity survive such a dramatic change? How would our world look after a few generations of doubled gravity? Let me know your thoughts in the comments below, and don't forget to subscribe for more fascinating explorations of the cosmos and the forces that shape our universe. The beauty of these hypothetical scenarios is that they help us appreciate the incredible complexity and balance of our world. Every force, every constant, every aspect of physics works together to create the perfect conditions for life as we know it. Thanks for joining me on this journey through a world of doubled gravity. Until next time, keep looking up and keep wondering about the incredible universe we call home.